Okay, day 2 is going to start with an application, and this application is when we do throwing what we call projectile. So an object is thrown or launched into the air. So think about hitting a baseball or shooting a basketball or kicking a soccer ball. And the general function we're going to use is this one, where the height after t seconds equals -16, which is what we use because of the Earth's gravity, t squared, plus v sub 0, which is the initial vertical velocity, times time, plus h sub 0, which is the initial height. And this is just a very basic, it doesn't account for air resistance or any of that. So, a soccer ball is kicked from ground level with an initial velocity. So, you might want to write down what your initial things are. So, initial velocity, that's your v sub 0, is 32. After how many seconds will the ball hit the ground? So, what is our initial height, or what do we want the height to be? We want our height, the end, to be 0. Okay, and we want, and our initial height, because we're starting from the ground, is 0. So you use your function, which is this. Substitute in things from -16 is given, v sub 0 is 32, and h sub 0 is already 0, and we want to know when it hits the ground. So we set it equal to 0. So we have, going to factor out a -16t, set each of those equal to 0. So you get t equals 0, which is our initial time, and you get t equals 2. So it would be 2 seconds, since our units are feet per second. Okay, so let's try to check it out together. We have initial velocity of 48. How long is the ball in the air? So that's going from 0 to 0. So our initial height is 0, and our end height is 0. So I'm going to just go ahead and substitute into the function factor set each factor equal to 0. This is my initial time, and this is how long it would be in the air. How do you know which values to use for VO and H sub O? V sub O is the initial velocity. H sub O is the initial height. How do you know which 0 the function to use is the answer? Because initially t equals 0 is the start. So it's the other answer. All right. Quadratic expressions can have 1, 2, or 3 terms, which we've seen. Those that have 2 terms are binomials. Those that have 3 terms are trinomials. There is our factoring of a difference of 2 squares and our perfect square trinomials, which basically think of this as if we just had this twice. Okay, it can be written as a minus b quantity squared. So let's find our roots. So that means we're going to set equal to 0 by using special factors. So the first thing you need to do is make sure that it equals 0 by moving the 1 over. This is a difference of 2 squares. And the process is the same as before, setting them equal to 0 and solving. So again, make sure it says equals 0 first. So I'm going to move the 40x over, and I'm going to put it in between the x squared term and the constant. I have a GCF I can factor out first. And this is one of those special cases. The 4 is a perfect square, the 25 is a perfect square. So, and it's a minus plus, so it's 2 minuses. And since each factor is the same, and you might want to just write down that it's a double root. Okay, try to check it out. I abbreviate double root as DR. Just makes it a little easier than writing it out. And hopefully you're able to get those relatively easy. What steps should you do before you factor the quadratic equation in these equations? Make sure it equals 0. How do you factor a difference of difference of squares? 1 plus, 1 minus. Think about the square root of the first term and square root second. So, for instance, it would be x plus 2, x minus 2. If we know the zeros of a function, we can work backwards to write the actual function. So write a quadratic function in the standard form with zeros, which means x equals 2, and negative 1. So now we subtract 2, add 1, and now we can put the 2 together to multiply, because they are factors, and then do our FOIL, x squared, first outers, inners last, and then combine our like terms in the middle, and there's our function. So again, I will do this one with you too. X equals 5, x equals negative 5. So I subtract 5, add 5. They are my two factors. Multiply that, and hopefully you know and recognize that as a difference of two squares. There is no center term. So f of x equals x squared minus 25. So closing this lesson, methods for finding the zeros of quadratic functions, graphing, and it's the points where the graph crosses the x-axis. And then factoring. Set the function equal to 0. Factor. Set each factor equal to 0 and solve. And this ends 5-3 lesson.